Number 10. Two friends, Amelia and Bill, each sets to themselves a target of saving $20,000. Well, good for them. 20,000. They each have 9,000 to invest. Amelia invests her 9,000 in the account that offers an interest rate of 7% per annum, which is per year, annum for annual, compounded annually. Find the value of Amelia's investment after 5 years to the nearest $100. All right, so this shouldn't be so bad because we know that A is equal to P times 1 plus the R over N. And T, again, R is interest rate, N is number of times compounded per year. And Amelia, awesome, is compounded annually, so both ends are 1. Awesome. So for Amelia, that's going to be 9,000, the initial amount, times 1, plus her rate is what? 7%. So that's 0.07 divided by 1, right? Over n divided by 1 is 0.07 to the 1 times how many years? 5 years to the 5th power. Now, I'd go ahead and do 9,000 times 1.07 to the 5th, right? Okay, so let's do that. All right, so I'm going to do 9,000 times 1.07 caret to the 5th power. Boom. Ooh, and it rounds to the nearest 100. Well, no, that's not rounded to the nearest 100. So we have 12,623, right? 12,623. Now to the nearest 100, this is the hundredths place, right? I look to the right, that's less than 5. So the 6 remains. I do not round it up to the to 7. So to the nearest 100, it's $12,700. No, what's the matter with me? I don't round it up. $12,600. Okay. All right. B. Bonk. Determine the number of years required from Amelia's investment to reach the target. All right. All right. So she needs her target of 20,000, right? That's her target. So we're just plugging in to this formula right here for A, right? We're plugging in for A. So A equals P times 1 plus R over N. So I'm just going to put R and I'm going to put T because we know that N is 1. So she needs 20,000 is equal to 9,000 times 1 plus 0.7. So I'm going to immediately write that as 1.07 just to save some time to the T power. They're asking how long, so it's how many years, right? So we're solving for T. So we would divide by 9,000. 9,000 equals 1.07 to the T. Now, we could totally graph this, Bernardo. We could graph it, but I'm going to show you a quicker way if we use logarithms. And you have your rules, and this is an easy one, okay? This is an easy one. Let me grab the log rules that we have right here. Now, come on, copy and paste. Don't mess with me again. Where is it? Okay. Okay, I'm on this page. I'm on this page. There it is. Okay, here's my rules of logs, and I'm going to get rid of it in just a second. Okay, I'm going to use the exponent rule, right? If I take the log of both sides, I can move the exponent out front. So I'm going to take log of 20,000. You know what? I'm going to make this even simpler to enter into our calculator. Whenever you have zeros over zeros, you can count out the least number they have in common. Cancel out. So these zeros cancel. It's the same as dividing by 1,000. So now it's just 20 over 9. Makes it a little bit easier to enter in our calculator. Log of 20 over 9 equals, and look at that, I didn't put this to the t power here. Shame on me. T power equals log 1.07 to the t power. And the whole reason I do that, log of 20 over 9 is equal to t times the log of 1.07. I can move t out in front, which means I can divide both sides by log of 1.07, and booyah, I'm in business, right? Because these cancel. And then I just have to put this in the calculator. That equals t. All right. So now I'm going to get this out of here. Right? Okay, get rid of those. Boom. Log of 20 over 9, log 0.17. So I need a fraction. Man, use the fraction thing. You're not going to make any mistakes. Or you're going to make less mistakes entering. Log, it's the log of a fraction. I don't have to put anything here because I'm using base 10. So I am going to put the fraction again. 20 over, move down here, 9. Down here, I need another log. Control log of 1.07. Boom. 11.802. So, extend page. T equals, what was it? 11.802. Now we have to interpret this, I think. You need to ask the teacher, right? Determine the number of years required for Amelia's investment to reach the target. Now, it's calculated at the end of each year. So it's not calculated in the middle of the year, okay? So again, check with your teacher on that to see if 11.802 would be acceptable. But I believe the answer is 12 years because the interest isn't calculated till the end of the year. But check with your teacher as to what IB has on that. All right, so now Big Bill, what's his problem? He invests $9,000 in an account that offers an interest rate of R% per annum compounded monthly. So that means N equals 12, right? Where R is set to 2 decimal places. Okay, great. Find the minimum value of R needed for Bill to reach the target after 10 years. All right, fine. So here we go again. A equals P times 1 plus R over N to the NT. The target is 20,000. 9,000. 1 plus, we're solving for R over 12. And then it's 10 years, so N times T is 12 times 10. So let's clean this up. I'm going to, again, look, I divided 20,000 by 9,000 here. Remember, it's 20 over 9. So I'm going to do 20 over 9 again. Equals 1 plus R over 12 to the 120. Not 1200, Dave, 120. R over 12 to the 120, right? I can solve this with logs too, Bernardo, using the same rule, and I think that's what I'm going to do. I mean, if you want to graph, then go ahead and graph. That's fine. But I think logs are easier if you're okay with them. If I take the log of both sides, I can bring this exponent down. Okay. So then log of 20 over 9 equals 120 log of 1 plus r over 12. Actually, no, because then I can't get rid of the r over 12. We're going to graph it on this one. I can't get the r out of here. Yeah, it's a big pain. My bad. So we're going to graph that bad boy. Okay. So I guess this time let's see where they intersect. How's that? You could have done 20,000, but 20 over 9 is a lot. You don't have to change your window. All right, so I'm going back to um, my graphing page, right? So boom. And I'm going to get rid of everything. I can do a new graphing page. I'll just do that. Add another graph, and off we go. So we are graphing 20 over 9 for one of the functions. 20 over 9. There it is. And then this horrific thing. 1 plus x over 12 to the 120th power. So tab 1 plus x over 12. Could have used a fraction bar there. I usually do. Raised to the 120th power. Let's see what happens. Okay, and they intersect there. This is not making sense because it should take longer than that. Right? It should take longer than that. So you might want to fast forward while I think. I don't know what happened. 20,000, 9,000, 1 plus r to the 12th is 10. Divide by 9,000 to the 120th power. Is that what I have? Okay, is there another value here? Menu. Oh, we're looking for the interest rate. We're not looking for time. Yes, this is totally fine. I thought we were looking for time. We're not. We're looking for the interest rate. My bad. So boom, boom, 0.08. Now, there is a way to increase the decimal places. You have to highlight it, attributes, and we need our precision to like 4. So let's do that. I did 6. Okay. So now this is better because they wanted it to 2 decimal places, right? So if, let me just capture that and throw it on the page here. Oop, it's the x value. And we get that for r. Ooh, I'm glad I figured out we're looking for the interest rate in that time. Okay. So, so r would be equal to moving the decimal place 2 places over. That would be 8.01%. 8.01. So if you need to add decimals on your calculator, just go ahead and do it. All right. I think we're sort of out of room, so I'm going to go to a new page to do D and E. Okay. So a third friend, Chris, also wants to reach 20,000. He puts his money in a safe where he does not earn any interest. His system to add more money to this is to add more money to safe every year. Each year he will add half the amount of money added in the previous year. Show that Chris will never reach the target if his initial deposit is 9,000. Well, let's think about this, right? So to figure out what we've got is a sequence here, since we're adding half of the amount. So we're going to start with 20,000, right? Plus 1/2 of 20,000. Plus, right? Okay, so we have 20,000. Let me do it this way. No, that's right. plus 1/2 of this previous term, 1/2 of 20,000. And hopefully you're seeing what we have is a geometric sequence, okay? Geometric sequence. And where's my eraser? Okay. And that u sub 1 is 20,000. And the common ratio is what we're multiplying by. It's 1/2. Now they're telling us to show he'll never get there to $20,000. He'll never get to 20,000. That means he could add, here's the big word, for the rest of his life infinitely and never get to 20,000. Okay? So we have to find the sum of this geometric sequence to infinity. So let me get the dealio here. Okay, boom. All right, we're going to go back to here. Yay, it worked. All right. So remember, the formula for infinite geometric sequence is not with this, it's lower down on the list. So the sum to infinity is equal to the first term over 1 minus the common ratio. So this would be 9,000. His initial investment is 9,000, right? So the first term is 9,000. Oh, wait, I totally messed up. I started with 20,000 as the goal. Oh my God, u sub 1 is 9,000. I'm so sorry. Hopefully you caught that, okay? So that would just change these guys here, here. Sorry. Oh my God. Okay, so it would be 9,000 plus 1/2 of 9,000 plus 1/2 of 1/2 of 9,000, okay? All right, so u sub 1 is 9,000. Woo! Nice going, Dave. All right, so same idea, 9,000 over 1 minus 1/2, which is equal to 9,000 divided by 1/2, which is 9,000 times the reciprocal of 1/2, which is 18,000. So he'll only get to $18,000 if he does it for the rest of his life. No, and then he has to live forever. So no good there. All right, boom. One more.